Okay, so the topic for this video is going to be classifying quadrilaterals on a coordinate plane. Our essential question is essentially the same thing, just how is it done? How are quadrilaterals classified on a coordinate plane? So, first little part here says classifying a quadrilateral on a coordinate plane can be done two different ways. The first of which is by examining its sides. And then it says let's consider A, B, C, D with A at -2, 0, B at 0, 2, C at 1, 2, 3, 4, 5, -3, and D at 3, -5. So we've got this quadrilateral here, A, B, C, D. And let's connect those, make our quadrilateral. Okay, so that's our quadrilateral. And we are going to algebraically prove that it is some sort of quadrilateral. I know that looks can certainly be deceiving at times. It certainly looks like it might be a parallelogram or a rectangle. But we need to mathematically prove that it is one of these different types of quadrilaterals that we've seen in previous videos. So step one, by using this method, is to find the lengths of the four sides. Now, finding the lengths means that we're going to be doing the distance formula. So we got four different sides to find the lengths of. Let's start it off with AB. Let's get our distance formula cooking here. So for the distance formula, remember that's going to be x2 minus x1 squared plus y2 minus y1 squared equals the distance. So for our x's here, I'm going to be doing 0 minus -2, which would be 0 minus -2. That would turn into 0 plus 2 squared. And then we'll be doing y2 minus y1, so 2 minus 0. And if we do that, we should get about 2.8 if I round to the nearest tenth. Next batch here for BC. Let's see here. So now we're going to be using the 5 and the 0 and the -3 and the 2. So 5 minus 0 squared plus -3 minus 2 squared. Let's see what we get when we do that. I'm getting 7.1. Now, just as a quick timeout, if we look at that, that's 2.8. Let me do that in red so it appears a little bit better. So AB was 2.8, BC was 7.1. So let's just keep that in mind as we're looking through this. So now let's find the length of CD. So now we're going to be using the 3 and the 5 for the x's and the -5 and the -3. You should probably have a guess as to what we expect to get. If our original assumption was correct that this thing is a rectangle, then that opposite side should be the same as the 2.8, right? So we're expecting to get 2.8 here, but let's see what happens. So this will be 3 minus 5. Oops, that is in highlighter form. So 3 minus 5. And then for the y's, we're going to be doing -5 minus -3, but minus a negative is plus. So that's 3 minus 5 and -5 plus 3. And I'm getting, let's see here, plugging that into my calculator, 2.8. So things are looking good for our rectangle theory. Last one to check, though, is side DA. So for that one, we'll be doing obviously DNA. So this will be 3 minus -2, which would be 3 plus 2. And this would be -5 minus 0. And let me type that one in. Hopefully we get another 7.1. And we do. Okay, so what does that mean for us? Well, it certainly looks like it's a rectangle, right? So what could ABCD be right now? There are two options right now. This could be a parallelogram, or it could be a rectangle. Those are the two types of quadrilaterals that have opposite sides the same and only opposite sides the same. They're certainly not all four the same. So I'm going to say parallelogram or rectangle because opposite congruent sides. Now, how are we going to be able to tell which one it is? How are we going to be able to tell if this thing is a parallelogram or if it is a rectangle? Well, the difference between those two is that the rectangle has right angles, right? So how do we tell if there are right angles? Well, we need to look at the slopes of the sides, okay? By examining the slopes of the sides, we'll be able to figure out if these lines are perpendicular or not, because remember, perpendicular lines have opposite reciprocal slopes. So now it is time to do the slope formula for our different sides. So for AB, zoom out a little bit here. For AB, if we're doing the slope formula, we need to do y2 minus y1 over x2 minus x1. Right, so this will be 2 minus 0 over 0 minus -2, or 0 plus 2. 2 minus 0 is 2. 0 plus 2 is 2. 2 over 2 is 1. Now for the slope of BC. For BC, we'll be doing -3 minus 2 over 5 minus 0. -3 minus 2 is -5. 5 minus 0 is 5. -5 over 5 is -1. Now, remember, slopes of +1 and -1, those are opposite reciprocals, so we do get a right angle between sides AB and BC. So that's one right angle. Now let's try CD. So for CD, I'll be doing -5 minus -3, which would be -5 plus 3, all over x2 minus x1, 3 minus 5. -5 plus 3 is -2. 3 minus 5 is -2. And -2 over -2 is +1. So once again, those are opposite reciprocals between the -1 and the +1 of BC and CD. So we do get a right angle in that corner. Now lastly, we just need to check side DA. That's going to be -5 minus 0 over 3 minus -2, which would be 3 plus 2. That's -5 minus 0, that's -5. 3 plus 2 is 5. -5 over +5 is -1. So once again, we get some opposite reciprocals, so we get a right angle between side CD and side DA. And also side DA and AB, those are opposite reciprocals, so we get a right angle over there. So we do confirm by checking the slopes to see if they're perpendicular that we do have right angles in here. So since we have those opposite sides that are congruent and we have the perpendicular slopes, this is a rectangle. All right, and I'll make a note over here that confirms that we do have right angles. So when you're checking a quadrilateral based on the sides, you do the distance formula to see what's going on with those sides, see if you've got all four sides the same, if you've only got opposite sides the same, that kind of stuff. That should lead you down the right track to narrow it down to just a few options. And then you'll check the slopes of the sides to see if you got right angles or not, because that's going to be the difference between, for example, a parallelogram and a rectangle, or the difference between a rhombus and a square, right? Some of those have right angles, some of them don't. All right, so on the inside, we're going to take a look at the other method we can use. which is going to be by examining the diagonals. All right, so let's look at our new ABCD here. So A is at -2, 2. B is at 1, 1. C is at 2, -2. And D is at -1, -1. So looks like this. So we got A, B, C, D. All right, so my first impression, this kind of looks like it could be a parallelogram or maybe a kite or a rhombus. Kind of hard to tell. So let's go through our method here and examine those diagonals. So step one is going to be find the lengths of the two diagonals. Now, remember, lengths means use the distance formula. So first up, we're looking at diagonal AC, going from that corner to that corner. So I'm going to be using these x's, I'm going to be using these y's. So distance formula time. Okay, so let's do 2 minus -2. 2 minus -2 would be 2 plus 2. And then for the y's, we'll be doing -2 minus 2. So let's see what we've got here. I'm looking at 5.7. Okay, 5.7 there. Now for BD, let's see here. BD, we're going to be using 1 and -1 for our x's. We're going to be using 1 and -1 for our y's also. So this would be -1 minus 1 and -1 minus 1. Okay. I'm getting 2.8. And that's going this way. Now, that didn't tell us too much, did it? It just told us that the diagonals are not congruent. All right, so if the diagonals are not congruent, that means it could be any sort of quadrilateral that doesn't have congruent diagonals. So that means that this could be a parallelogram. Parallelograms don't have congruent diagonals. A rectangle does, so this is not a rectangle. A rhombus does not, so it could be a rhombus still. A square does have congruent diagonals. An isosceles trapezoid does have congruent diagonals, but a kite does not. And why is that? Just what we said, not congruent diagonals. All the other options do have them. The isosceles trapezoid, the square, the rectangle, those all have congruent diagonals. Okay, so now we're going to check out the slopes of the two diagonals. Now, the reason that we're checking out the slopes is because we want to see if these lines are perpendicular or not. Because if they're perpendicular, they got the right angles, and that's going to eliminate some options. So find the slopes of the two diagonals. Okay, so slope of AC. Remember, slope formula is y2 minus y1 over x2 minus x1. So this should be -2 minus 2 over 2 minus -2, or 2 plus 2. So -2 minus 2 is -4. 2 plus 2 is 4. -4 over 4 is -1. And that looks good to me. It's going down for sure. Now slope of BD. So BD, y2 minus y1 would be -1 minus 1. x2 minus x1 would be -1 minus 1 as well. So -1 minus 1 is -2. -1 minus 1 is -2. -2 over -2 is +1. So we did get some opposite reciprocals there, which means they're perpendicular, which means we've got a right angle in there between those two. So what does that mean for our quadrilateral? Well, which of those options that we listed on the last step do have perpendicular diagonals? And that is the rhombus and the kite. Right, the rhombus and the kite are the ones that do have perpendicular diagonals. So now we need to figure out, is this a rhombus or is this a kite? Now the difference between a rhombus and a kite, according to their diagonals, is that the rhombus's diagonals cut each other in half. They both bisect each other, whereas the kite only has one that bisects one of them. So in order to tell between those two, we are going to be looking at the midpoints of these two diagonals. If we get the same midpoint, that means that those diagonals did in fact bisect each other. So let's do a little midpoint formula here. So for AC, the midpoint formula looks like this. We do x1 plus x2 on top, and then y1 plus y2 on top for the other one. So x1 plus x2 for the midpoints of AC, we would be doing -2 plus 2. And then for y1 plus y2, that would be 2 plus -2 or 2 minus 2. So -2 plus 2 is 0, divided by 2 is 0. And then 2 minus 2 is 0, divided by 2 is 0. So the midpoint of AC is right at 0, 0. Now for BD, let's do the same thing. For BD, we'll be doing x1 plus x2. That's 1 plus -1, or 1 minus 1. And then for y1 plus y2, that's also 1 plus -1, or 1 minus 1. 1 minus 1 is 0, divided by 2 is 0. 1 minus 1 is 0, divided by 2 is 0. So we got 0, 0 for both midpoints. Now what does that mean? Once again, that means that the diagonals bisect each other. Because if they both have the same midpoint, that means that this diagonal is cut in half right at 0, 0, and this diagonal is cut in half right at 0, 0. So that point right there, the origin, is the midpoint of both diagonals. So our diagonals, we found out, are not congruent by doing the distance formula. They are perpendicular by doing the slope formula. And they do bisect each other by looking at the midpoint formula. And that only happens in the rhombus. If we happen to get two different midpoints on step 3, it would have been a kite. Okay, so what we have for this last part, I know that these problems can take a while because there's a lot of calculations. So these ones are just giving us the results. It says classify quadrilateral ABCD given the following information. So by looking at this one, we can see, at least by looking at the results of the side lengths, that we do have 4 congruent sides. Now, just based on that, if we have 4 congruent sides, there's 2 options. It's either a rhombus or a square. Those are the only 2 quadrilaterals that have 4 congruent sides. Now looking at the slopes over here, we can see that the slopes are opposite reciprocals, right? Between those two, they've been flipped and they've changed, right? That's an opposite reciprocal. So that means that we do have 4 right angles. And the quadrilaterals that have 4 right angles, well, that's either a rectangle or a square, right? Those are the ones that have 4 right angles. So if we know that it's either a rhombus or a square over here and a rectangle or a square over here, that thing must be a square. Okay, let's look at this one. So this one's done it according to the diagonals. So we can see on step 1 that we do have congruent diagonals. I'll just say congruent diags. Now, which quadrilaterals have congruent diagonals? Well, there's 3 of them. There is the isosceles trapezoid. There's the rectangle. And there's the square. Now looking at the slopes of the diagonals, we can see that they're opposites, but they're not opposite reciprocals, right? So out of those options that we just listed, we do not have right angles. And out of the options that we had, the isosceles trapezoid and the rectangle and the square should have right angles. So if we can see that they're not opposite reciprocals, so we don't have right angles, that means that we can eliminate the square. So now we're just down to the isosceles trapezoid and the rectangle. We no longer consider the square because the square has to have the perpendicular diagonals. And then we look at the midpoints, and we can tell that they don't have the same midpoint, right? And if they don't have the same midpoint, they don't bisect each other. So I'll say they do not bisect each other over there. And if they don't bisect each other, that means that it can't be any of the parallelograms, including the rectangle. So our only option at this point is the isosceles trapezoid. That is the only quadrilateral that does have congruent diagonals, but those diagonals are not perpendicular and they do not bisect each other. So hopefully you can see why we eliminated those options at each step, right? We started off by considering every single one that has congruent diagonals, but then we eliminated the square after we saw that they weren't perpendicular, and we eliminated the rectangle after we saw that they didn't bisect each other. Okay, this last one, back to looking at the sides. So first up, I can see that all four sides are not the same, but we do have these opposite ones being the same. So I'll say opposite congruent sides. And right away, what does that mean? The only quadrilaterals that just have opposite sides being the same are a parallelogram and a rectangle. Then I look at the slopes of the sides, and I see that they are not opposite reciprocals, right? They are not being flipped and changed, which means that there are no right angles. So out of our two options of the parallelogram and the rectangle, the only ones, the one that doesn't have the right angles is the parallelogram. And there we go. So hopefully you can kind of see the thought process that you have to be going through. You really got to consider all the properties of these different quadrilaterals. Got to keep those in the back of your mind, or else you're going to be lost. So for the your turn here, you've got one big problem that you're going to try to do. And it is by looking at the sides. So it's like the first example that we did. So try to classify this thing and come back to see how you did once you've got your answers. All right, so let's see here. A was at -2, 0. B is at 0, 1. C is at 2, 0. And D is at 0, -4. So A, B, C, D. All right, so step one here, we got to check out the distances on these sides. And let's see what happens here. So for AB, do the distance formula. I'm going to be doing 0 minus -2, or 0 plus 2, and 1 minus 0. And that should be 2.2. For BC, When I do it here, I'm going to be doing 2 minus 0 and 0 minus 1, which should also give me 2.2. For CD, I'm going to be doing 0 minus 2 squared and negative 4 minus 0 squared. Which should give me 4.5. And then for DA, I'm going to be doing 0 minus negative 2, or 0 plus 2 squared, and then negative 4 minus 0 squared, which should also give me 4.5. So this is kind of interesting. Honestly, at this point, I kind of already know what this thing is. The only type of quadrilateral that has those consecutive sides being the same but not opposites is the kite. So for my reason, I will say consecutive, congruent sides. Let's still go through the process, though, of finding the slopes just to make sure. So slope of AB, I should do 1 minus 0 over 0 minus negative 2, or 0 plus 2. That's going to be 1/2. For BC, I will do 0 minus 1 over 2 minus 0. And that'll be negative 1/2. For CD, I will do negative 4 minus 0 over 0 minus 2. That is negative 4 over negative 2, which is 2. And then for DA, I will do 0 minus negative 4, which would be 0 plus 4, over negative 2 minus 0, and that will give me 4 over negative 2, which would be negative 2. And we can see that those don't form any sort of right angles. None of the consecutive sides are perpendicular. Well, actually, you know what? We do actually have 2 right angles. That's kind of interesting. We do have some perpendicular lines between this and this. So we do have a right angle there. Right there. And we do have a right angle actually between these two. Which means that we do get some right angles in those corners, which is kind of interesting. But that's not enough to actually classify it as anything different. This thing is officially a kite. All right, hopefully that went well for y'all, and that's going to wrap up this video.